Is it what? Computer science. Okay. Okay. So let's look at, let's go to graphical techniques. Let's go to graphical techniques for organizing data. Huh? Let's go to graphical techniques for organizing data. Now, we had mentioned several graphical techniques for organizing data in the last class, okay? We are going to be very fast with getting each of them done. We are going to be very, very fast with getting each of them done. You have to control that. We are going to be very fast with getting each of them done. So, the first one we are going to be looking at, we are going to take them one after the other. The first one we are going to be looking at will be, which one did we itemize? I think the first one was the pictogram, right? Good. So that's the first graphical technique we will be using or discussing in our class. Okay? Remember, we are still under organization of data. And we had gone through different things you need to know about organization of data up to this point. So, question is, what is a pictogram? Okay? You see, the reason why people use graphical techniques for organizing data is simply because most people do not like the mathematical side of things. They understand things better when you want to present, if you want to present something to someone and you want it better understood, some people prefer you show them pictures. Is it clear? People understand better with what? Pictures. As such, graphical techniques in statistics can help one organize data and also make whoever would use that data appreciate the data in the form it comes out. Let me give you an instance. For example, let's say that you walk into a maternity ward where babies are born. Okay? Now assume yourself to be a doctor. Okay? And you walk into a maternity ward, let's say your shift starts from 8 o'clock in the morning and will terminate at 12 in the afternoon. Now, I hope you know all the ladies in the room, all the pregnant women in the room will not just hold hands like footballers and tell themselves, let's all deliver by 8 so that we can go home. Eh? They won't do that. You know so? They will deliver as it comes. You get me? So there is every tendency that between the hours of 8 and 8:59, some women will deliver, or no woman might deliver. You know so? It's a possibility. Then from 9 to 9:59, you could have one woman delivering, you could have several women delivering, you could have none delivering. You know so? So if you categorize 8 to 12 into groups, the doctor might come in now and ask summarily, if you were the one who was just on duty, he could ask you how many women delivered between the hours of within 8 to 8:59, and would need you to provide answers. Is it not so? And you'll be providing figures. If there were 20 women that delivered during that period, you will give him 20. And if he demands to know the number of students and number of women who delivered between the hours of the minutes of 9 and 9:59, you also supply numbers. Now, some people, you may understand numbers, you may understand and appreciate numbers, but I can tell you some people do not. Some people would appreciate that information if you show them with graphs or with pictures that this is how it happened. So when you narrate an event using pictures or graphs, people appreciate them better. That is why under organization of data using graphical techniques, the use of different graphical techniques can help you appreciate data better. So let's start with the pictogram. The question we want to answer now is, what is a pictogram? So please write, everybody. A pictogram is a diagrammatic or pictorial summary of data usually obtained from the field. So I hope you remember that we had said that when data is obtained from the field, it is called what? Raw, right? Because it is unprocessed. So when you get data from the field, your choice of summarizing the data might be the use of what? Pictogram, okay? So a pictogram is a diagrammatic or pictorial summary of data, usually from the field. Let's add a statement here. Using conventional pictures or symbol. Using conventional pictures or what? Symbol. Now, I won't waste much time. I will go quickly into telling you the advantage. So, first paragraph tells us what a pictogram is. Do you understand me? It is the use of diagrams or pictures to summarize what? Data that you obtain from the field. And these pictures or symbols or diagrams used are conventional. Please take note, the word conventional in this sense means an agreed set of symbols. So if somebody says, coming into this class, why is everybody putting on black shoes? You can simply tell the person by convention, today is Wednesday, right? By convention, every Wednesday in our department, we ought to wear black shoes. That conventional or convention means that it is an agreed thing amongst a group of persons that this is what should be. Is it clear? So all over the world, there are symbols. Okay, let's go to physics, for instance. In physics, if we write this, it will refer to what? What will it refer to? Your mind will go to ohms, right? Good. Now, there are symbols in physics, chemistry, different fields in academics that are dedicated to one specific thing, such that wherever you see them in the world, you just know that this is what it means. Do you understand me? And the only reason why we would all accept it is because by convention, those symbols are dedicated to describing that thing. Is it clear? So, we would be using conventional pictures. Let's go to the next paragraph. In the next paragraph, please, I want to state the advantage of the pictogram. So we are going to write the advantage of the pictogram. The advantage of the pictogram is that it makes data presentation comprehensible and simplistic. So when you use the pictogram, data organization becomes simple. It becomes something that one can just look and easily understand or comprehend. Is it clear? So data presentation with the data organization with pictogram does that for you. It makes the presentation very comprehensible and what? Simplistic. However, there is a disadvantage. So we are going to put the disadvantage in the next paragraph. However, the disadvantage of the pictogram is that it is not efficient. It is not efficient for representing. It is not efficient for representing fractional data. I'm going to explain all these things, okay? It's not efficient for representing fractional data. More so, there is another disadvantage. More so, the pictogram uses symbols that are often not widely acceptable for representing fractional data. So, that being said, let me use this example to explain. Okay? So please, in my hold on. In my class, when my class begins, please take note, everybody. I like using from when we start to when we finish all our topics, all the example numbers so that we can refer, all the figure numbers so that we can refer. We'll go table numbers, they will go like that. We'll be naming our tables, we'll be naming our examples. So this is example 1. Is it clear? Even when we get into, if the last example in this topic is example 10, when we go into the next topic, we will continue with example what? 11. Is it clear? So that I can actually refer you to, please go back to example 1. We need the data in example 1. Is it clear? So let's take example 1 to explain this. So let's consider this example. The data below is a summary. The data below is a summary of the number of deliveries. Number of deliveries per time period in a given hospital ward. Please, in the next 10 minutes, I'll be done. Okay? Hospital ward. Use a pictogram to describe the data. Use a pictogram to describe the data. Okay? Now, please, can I wipe this off? Okay. Use a pictogram to describe the data. So let's see something. Please look up, everybody. Now, let's put a remark. Is this my first remark or my second remark? I think this is my second remark, right? So I'm going to put here remark number 2. In the last class, I think I made a remark. I didn't say remark. Are you sure? Okay, read through. Okay, so we should take that as remark number 1. Okay, good. So remark number 1. Now, some of the conventional symbols, before we answer that question, some of the conventional symbols or pictures used in pictograms are 1. You could have the apple, which is usually of this nature. Okay. 2, you could have what do you call it? You could have the cross. You could have the cross, which is often used. 3, you could have the banana, which is often used also. Then you could have the circle, often used. You could have what do you call it? The triangle. The triangle. You could have the square and rectangle. You could have that also. Now, let's put etc. here. So, all these are conventional symbols used in what? The pictogram. Is it clear? Now, let's see how that is used. Let's see how that is used. So, let's bring the data back here. But before that, let's also put this down. Of all the conventional symbols listed above, of all the conventional symbols listed and available for pictograms. Of all the conventional symbols listed and available for pictograms, the circle is the most flexible. the most flexible? Please, look up everybody. See, you see all these symbols. If you are to use the pictogram, all of these symbols or pictures can be used. Is it clear? You could decide to use the apple. You could decide to use the cross. You could decide to use the banana. You could decide to use the circle. You could decide to use triangle or what? Or squares, rectangle. Is it clear, everybody? Now, we are going to come to how we are going to use them. They are very simple. Okay? We won't dwell on this. But take note, out of all of them you see here, the one that is mostly used because of how flexible it is, not based on sentiment, but based on geometry. Now, is the circle. Let me tell you something. Look at it this way. When I was a little boy, there used to be a problem whenever we share things at home. Okay? You know the way, if, for example, I ask you this question, your mother brings home, let's say you guys are many in your house, so your mother brings home banana from the market and decides that it should be two persons to one banana, two persons to one banana. Now, and you happen to be, okay, let's say you happen to be living with your cousin such that you and your cousin are age mates. It's not a case of your elder brother such that you will say, I am the senior. Therefore, you will take small, I will take big. It happens to be your cousin who lives with two people. The mother now says, so you and your cousin take one banana and share. Because you know two of you are age mates. He is 17, you are 17. And the person now say, you now say, okay, let's share into two equal parts. At what point in a banana would you say is half the banana? I hope you know, towards the head of what you call the head of the banana, it is bigger. As you move down, it is what? Smaller. Now, the guy may say, literally, half should be what appears to be the middle. Is it not so? But if he cuts the middle, from that middle down to the bottom, it will be small. And from that middle to the top is bigger. Is it not so? So, if you use a pictogram and decide to use a banana to describe 50 as half, so let's say 100 is full and 50 is half. You want to use a banana to your pictogram to represent half of 100, which is what? 50. You may put a message here in Nigeria that half a banana represents 50 and send that information to a Japanese mathematician and he will say, what is half a banana? Because theoretically, half a banana should be, in his own opinion, cut like this, not horizontally, but cut what? Longitudinally. You understand me? So different opinions will be coming up as a result of the use of what? That symbol, banana. Again, if you move away from banana and you move to triangle, question is, geometrically, those of us who did geometry in secondary school, at what point would you call half a triangle? Half a triangle, how would you cut a triangle to make half of it? Because except it is an equilateral triangle, it may be very, very difficult to say half of a triangle. If it's an isosceles triangle or it's a scalene triangle, you won't know where to say half is, right? If you move over also to the cross, a cross is such that the top, you have the longer part down. Is it not so? Where is half a cross? Is half a cross this? Or is half a cross this? Such that from here to here, or is half a cross this? It causes ambiguity. You get me? If you move over from a cross and go to a human being, please, I didn't even add human being. You must have seen such. Have you seen this symbol? Now, half a human being. What is half a human being? Could it be half a human being is a human being with two hands, head, and no legs? Could half a human being be a human being with two legs, no hands? Or could half a human being be half head, like this? Or could half a human being be like this, complete head, one hand, one leg? So different opinions will be coming up as to what half a human being should what? Be. But the only symbol out of all of them in a pictogram that once you present half of this, a quarter of this, is what? The circle. Because we were told in geometry that half of a circle is what? A semicircle. So there's something like half a circle. Is it not so? And we were also told in geometry, precisely in trigonometry, that half of a semicircle is what? It is what? A quadrant. Is it clear? So that is the reason why, because you can accommodate half in a circle, you can accommodate a quarter in a circle. That is the reason why a circle is what? The most flexible among all the symbols available for what? Pictograms. I hope everybody understands me. Thank you very much. Now, let's use this example and call it a day because I'm the one that was late, okay? So it's not your fault. I can't put it on you. So let's put the data. So this is my data, everybody. Can I wipe this off? Thank you very much. Now, this is my data. This is my data. So let's put the data for that example. So these are time, we are going to put here time periods, okay? Time periods, and we are going to put here number of what? Number of delivery. Is somebody following? So I'm going to put here 8 to 8:59. That is, let's put on AM, okay? Then I'm going to put 9 to 9:59, 10 to 10:59, and 11 to 11:59. Nigeria is very difficult, but the rate at which you go to every hospital, you will discover that no matter how difficult Nigeria is, there are so many pregnant women. So the men are very busy. I don't know if it is anger or frustration that is making them. Despite how hard Nigeria is, people are doing their responsibility. So we have to really thank God for the men. They may not have money, but they have something to get a woman. So it includes me. Oh, good. It includes me. No matter how hard Nigeria is, I must perform. So when my wife came back to tell me that, do you know that even when you go 8 o'clock in the morning, I will still sign in as 102. My number will still be 102 at antenatal. I said, what? In this Calabar? And when I said, what? I will not ask her. But Nigeria hard. Why are people impregnating their wives? The question is, am I not among? Or the hardship is not touching me? So let's now assume, using the number that my wife gave me, that just when you think it is impossible, from 8 to 8:59, how many women were born? I'm telling you, it can be more than 102. So 102, according to my wife, is the smallest number. So the women are not tired. So let's put here 159. Let's put here, let's picture this one, 57. And let's put here 95. Good. So let's see. Okay, for a start, let's change these figures for now because of something. Let's maintain 95 here. Let's put here 100. Okay. Let's put here 150, and let's put here let me change here to 70 for a particular reason, and then I'm going to change here to 50. Good. I will explain why. Now, if I tell you to use a pictogram, please take note, everybody. For you to use a pictogram to describe this data, you must first of all choose your own suitable key. So, in this example, what I'm going to do, I'm going to say, as my solution to the problem, I'm going to say, let one circle, that is, be equal to, let one circle be equal to 20, let one circle be equal to 20 deliveries. You see it? Now, I'm going to explain why. If you say let one circle be equal to 20 deliveries, then the solution to your problem becomes this. How would your histogram now come out? That information in that table will now become 8 to 859 would now be what? How many circles do you have in 100? If one circle is representing 20 deliveries, you have what? 1, 2, 3, 4, and what? 5. So 5 circles will represent what? 100. So once I see 100, when you've told me that one circle equals 20 deliveries, I know that there were 100 deliveries. Is it clear? So 9 to 959, how many deliveries? 150. So I'm going to put 1, 2, 3, 4, 5. That's 100, right? 6, that's 120. 7, that's 140. And then what? Half. A semicircle. You see it? Hey, Baba, hold on. So then 10 to 1059. How many deliveries? 50. That will be what? 1, 2, and what? Half. Is it difficult? Then what happens at 11 to 11:59? You will now have what? 1, 2, 3, and then what? Half. You see? Now, if you chose to do otherwise, if you chose a wrong key, let's assume you chose your key as let one circle be equal to 50 deliveries. You won't have a problem with this one. You will need 2 circles, right? You won't have a problem with this one. You will need 3 circles. You won't have a problem with this one. You will need what? 1 circle. Is it not so? But when you come over to this one, you will have 1 circle, which is 50. But the question now is 20 on top of 50 will now be a fraction. And that takes me back to the demerit or the disadvantage of what? The pictogram generally. It is inefficient for representing what? Fractional data. Because no matter how flexible the circle is as a conventional symbol for use in what? Pictogram, you will still encounter a problem with knowing how to segment a circle to get 20. You see it? So that is the problem with what? The pictogram. I hope everybody understands this. Huh? Good. So we are going to round up here. Let's stop here for today. But in my class on Monday, next week Monday, we will be very, very detailed and I will be on time. Is it clear? So please, I want you to be in that class and I want you to be very, very attentive. We will be very detailed and very elaborate. So thank you very much. Okay? Thank you very much.